Okay, dear student, let's see what is there in this question. A fixed mass of an ideal gas is contained in a cylinder closed with a frictionless piston. The volume of the gas is this when the temperature of the gas is 37 degrees centigrade. The pressure of the gas is this. Calculate the number of gas particles in the cylinder. So, number of gas particle means that you need to first find the number of moles. Straightforward. This is from the topic 3, and you are not even talking about the thermodynamics or something else, so that should be easy. Like we would be having the equation PV is equal to nRT, and accordingly we will find the number of mole. Pressure is 4 into 10 raised to power 5. Volume is 2.5 into 10 is 1 negative 3. R will be taken as 8.314 and the temperature will be 37. So 273 plus 27 is 300. So this will be 310. This is the number of moles. And accordingly, like now we know what is number of moles. So we can multiply this with the Avogadro number to find the total number of gas particles. I think nothing more than this. So N is equal to number of moles multiplied by Avogadro number. So I will not be calculating this. We will directly move to the mark scheme and see if they have done the same thing. If you have the calculator, you want to do it, you can do it now and we will see the answer. Okay, so the answer is here. So by using PV divided by, okay, so they are using the Boltzmann constant, but it's exactly the same thing. Boltzmann constant is the universal gas constant divided by the Avogadro's number. Technically, they have done exactly same thing that we did. So the answer will be this exactly. Let us move to the next question now. Energy is now supplied to the gas, and the piston moves to allow the gas to expand. The temperature is held constant. Okay, the energy is now supplied to the gas. So the energy is supplied, the piston moves to allow the gas to expand, so volume increases, temperature is held constant. So now this is kind of isothermal process. Discuss for this process the changes that occur in the density of the gas. So clearly, because the cylinder piston arrangement is a closed system, so mass is not allowed to go out, neither we can add the mass. So mass is constant in the volume. If the mass is constant and the gas is allowed to expand, it is having more volume. So density is equal to mass divided by volume. Clearly the density is going to reduce. Nothing to think about it, isn't it? So density is definitely going to reduce, there is no doubt about it. Now there is another thing that we can do. uh, I should not be telling you this thing, by the way, but if there is another explanation also. PV is equal to nRT. N can be taken as mass of the gas divided by molar mass, and volume can be taken as mass divided by the density. So this mass and mass gets cancelled out. This is how we create a relationship for the ideal gas in the terms of density. Okay, so from here we want to find like what is happening to the density. So it means like, see, the molar mass of the gas is not going to change, the universal gas constant is not going to change, the temperature is kept constant, even that is not changing. It means that pressure and density, they are directly proportional to each other. So rho is directly equal to P. Now if the volume is increasing, the pressure is reducing. If pressure is reducing, it means density is also reducing. So this is how you do it for the ideal gas from the ideal gas equation. But also in a straightforward manner, you can say density is equal to mass per unit volume, and then mass remains same, volume is increasing, density is decreasing. Okay, let's see what is next. Discuss the change that occurs in the internal energy of the gas. Another very important part of these kind of topics is internal energy. I tell you, the formula for the internal energy is N CV delta T. Now, you might not be knowing what CV is. CV, see, in the gases, the specific heat is of two types. The first one is specific heat at constant pressure, another is specific heat at constant volume. Because there will be two different methods in which heat can be given to it, and the whether the expansion is taking place or not. If the expansion is taking place, then the more heat is required to raise the temperature, isn't it? Obviously, because it has expanded, that is why. Overall, the internal energy formula is given by NCV delta T, and CV is also having a formula. So that will be taken as 3 by 2 NR delta T. Yeah, 3 by 2 R. So CV for you people means the students, those who are preparing for IB, because for you, for IB, the gas that they use here, the ideal gas is thought to be monoatomic, but in many other education systems, diatomic gas is taken to be ideal gas. Like here in India, we don't take these values in Indian education system. In CBSs and others, we assume diatomic gases for these questions. But this is specific to IB that they choose 3 by 2. Anyways, so your answer will be this. Now, if delta T is given, 3 by 2 n nRT can be written as P delta V. It can also be written as 3 by 2 V delta P. Let me be very clear here. All the formulas are same. They can be derived from ideal gas equations. Nothing new in this. 3 by 2 NR delta T must be given in the data booklet also. The CV thing is new for you. So if the change in temperature is given, you can directly apply the value. If let us say you're talking about the isobaric process, we use this. For isovolumetric, it becomes this. It becomes this. Nevertheless, the internal energy is thought to be dependent only and only on change in temperature. If the temperature is not changing, internal energy is not changing. Internal energy is directly proportional to the kinetic energy. So you might remember that formula EK 3 by 2 kBT. This is average kinetic energy per molecule, isn't it? This formula 3 by 2 nr delta T is having direct relation with this formula. So this formula you must be knowing it earlier, isn't it? That is directly related to this thing. Only thing is that in the case of kinetic theory of gases, we just use this formula for the kinetic energy. And in this case, we talk about the internal energy because qualitatively we have changed our topic. We are now talking about thermodynamics. So this is our basic formula. But if delta T is not given, but you're talking about some isobaric process or isochoric process, then you can directly use these two formulas. Okay, now coming to the question, temperature is held constant, which clearly means that there is no change in internal energy. So answer is zero. Answer is zero. It does not depend upon pressure, it does not depend upon volume, it depends only and only on temperature. Okay, so this is done. Let us now go for the next question. Okay, so the question is over, and let's see the mark scheme. Yes, so this we have done. The density decreases, and in the third case, question: internal energy is constant. Internal energy depends upon kinetic energy or the temperature only. It does not depend on anything else. If the change in temperature is zero, change in kinetic energy is zero, then the change in internal energy is also zero. That's it. Okay, dear students, thanks for watching the video. See you in the next video. Please share the video with all your friends. All the best. Bye.